chemistry HL paper 1 B part, which was earlier paper 3 part A. Okay, paper 3 had two parts, part A and part B, and the part A was your this paper. So we can say more or less this paper 1B is paper 3 part A, and this paper 1B basically it is based on data analysis. You will get question of data analysis type or data interpretation type, which are directly or indirectly related to your course or experimental work. This is a specimen paper given to us by IB. Since no other papers are available, there's a new course introduced. Hence, we are going to do this paper as a specimen paper of IB. And as you can see, the total paper is of 75 marks, which is 1A and 1B. And out of that, 1B, which is your data analysis, is of 35 marks. 40 marks is MCQ, plus 35 marks is my 1B. Okay. Now, if I move to the question of this paper, the first question is hypochlorous acid is a sterilizing agent used in swimming pools, and it is produced when chlorine reacts with water. So when we add chlorine as a disinfectant to water, it will react with the swimming pool water and forms HOCl. This is the basic of this question. Now what is asking you, deduce the oxidation state of chlorine in the reactants and the products. The first is given as a reactant is Cl2, chlorine, and in this Cl2, chlorine is an elemental state of chlorine. Cl2 is an elemental form, and for all elemental forms the oxidation number is 0. Therefore, the oxidation number of Cl2 here will be 0. Whereas in case of HOCl, the chlorine is bonded to two nonmetals, one is hydrogen and another is oxygen, and for hydrogen, whenever hydrogen is bonded to a nonmetal, its oxidation state is +1. For hydrogen it is +1. For oxygen it is always -2. For oxides it is -2, plus X for chlorine, which I have to determine, and that is equal to 0 because it is a neutral compound. Therefore, the value of X comes out to be +1. You have to always write plus or -1 whenever you are talking about oxidation state. Always plus and -1, or the charges should be written. In case of HCl, again, chlorine is bonded to hydrogen, which is a non-metal, then it is +1 for hydrogen, plus X for chlorine, and that's equal to 0 again. Therefore, X comes out to be -1. So what your answer is? Our answer is +1, -1 and 0. If all of these three parts are correct, 0, +1 and -1, then I will get a 2 mark for this. If any one part is wrong, then I will get only 1 mark for this, if any one part is wrong. Got it? So this is the part 1, in which is this question is directly related to your oxidation states, which is your redox, which is reactivity 3.2. Now next question is, explain why more chlorine reacts with water when NaOH is added. There are two parts. When we are adding NaOH, more and more chlorine is reacting. If we move to the question back again, we can see HCl is a product, and when I am reacting NaOH, when I am adding NaOH, HCl and NaOH will react with each other. They will react to form salt and water, and due to the formation of salt is formed, HCl has been removed, and when HCl is removed or used up, as per Leach's principle, the reaction should move in forward direction, and more chlorine should react or dissolve with water. So what I will write is, HCl is removed by sodium hydroxide, which is a base, NaOH. Thus, reaction moves in forward direction, that is right hand side towards product side, that is more of chlorine will react. Questions part C. The question says, researchers studying the solubility of chlorine in pure water at different temperatures and compile the following data from different sources. They had collected the data from different sources. Sources are A to F. These are the source, and they also collected the data at different temperatures. And the solubility of chlorine, the data they collected in terms of solubility of chlorine is it is given 1.46 per 100 centimeter cube, 310 per 100 centimeter cube. It's gram, it is centimeter cube. So what I see here is the data collected is in different units and in different volumes also. 600 milligram per 1000 centimeter cube, and so on. So what I see from this data is the data has been collected from different sources in terms of different units. Now my question is, identify the problem in comparing the data from different sources. Now when we are comparing the data, what is the essentiality of comparison? There should be a fair test. Fair test should be there, and fair testing can be done when the data collected from different sources have same units. It should have same units, same way of collection, same, there should be the variables should be in controlled way, that is whatever variables we are taking, they should be controlled. Now when I'm taking or collecting the data from different sources, I see they are not in the same units. They are in different units, different ways of measuring them. And since somewhere I'm measuring in grams per 100 centimeter cube, somewhere I'm measuring in 310 centimeter cube per 100 centimeter cube, and so on, milligrams gram. So what is the problem in comparing here is there are different units. I can write the answer is different units of measuring amount of chlorine in water, and that will not result in a fair test, and that can be a problem. Okay, different units, different ways of measuring, or different units of measuring, I can say. I can also write different ways of measuring. Okay, so this is the answer for part 1. Part C, C1. Next is the units of solubility are converted to mole per dm cube. Now I am converting all the units to mole per dm cube, and we converted these units of solubility from gram per 100 centimeter cube to mole per dm cube. When I am converting them, the part E is not converted. It is 177 centimeter cube of chlorine per 100 centimeter cube of the solution or water. Now I have to convert it into mole per dm cube. So first I have to find out the moles of chlorine, and by the help of this is your volume. This is the volume of chlorine given to you, and this is the density of chlorine given to us. Density is 2.86 gram per centimeter cube per dm cube. I have to convert this density. I can, by the help of this density, I can find out the mass. Density we know that is mass upon volume, and mass equals to density into volume. Now volume is given in centimeter cube and density is given in gram per dm cube. I will convert the volume to dm cube, that is 177 divided by 1000, that is equals to 0.177. okay, dm cube. This is my volume of chlorine. Therefore the mass of chlorine will be equals to 0.177 into density, and density is 2.86. When I multiply 0.177 with density 2.86, I'll get 0.506 gram per dm cube. Gram. This is 0.056 gram. This is the mass of the chlorine. I find it out with the help of this. Now after that I have to find out the moles of chlorine. Moles of chlorine is the mass divided by the molar mass. What is the mass? Mass is 0.506 divided by the molar mass of chlorine is 70.9, and this comes out to be 0.506. So when I calculate it, 0.506 divided by 70.9, if I calculate, I get 0.506 divided by 70.9, and that comes out to be 7.13 into 10 to the power minus 3, that is 7.13 into 10 to the power minus 3 mole. I get this. Okay, now I have to find out the concentration in terms of dm cube. Now concentration will be equals to moles upon volume. Moles upon volume. Volume is 100 centimeter cube because it is per 100 centimeter cube. Moles upon volume. My concentration will be, moles is 7.13 into 10 to the power minus 3 divided by volume is 100 divided by 1000, that comes out to be 1000, and when I calculate it comes out to be 0.0713. that is the answer. 0.0713. 7136, that is 714 I can write. Okay, this is the answer of the part. Question is, suggest an explanation for the effect of temperature on the solubility of chlorine. We have to find out the effect of temperature on solubility of chlorine. If we see the data from 0, 20, 10, 25, 30, temperature is increasing, and the solubility is 0.206, 0.13, 0.99, and this was calculated was 0.0714. So I can see the solubility is approximately goes on decreasing. Solubility is decreasing with increase in temperature. Temperature increases, the solubility of chlorine goes on decreasing. So it means the dissolution of chlorine in water, dissolution of chlorine in water is an exothermic process. Is an exothermic process. Why? Because as temperature is increasing, the solubility goes on decreasing. Solubility of chlorine decreases, goes on decreasing. So by this I can say it is an endothermic process. Dissolution of chlorine is an endothermic process, is endothermic in nature. Okay. Now if I increase temperature, the solubility will decrease. This should be the answer. Suggest an explanation for the effect of temperature on solubility. If I see dissolution of chlorine is exothermic, temperature is increasing, solubility of chlorine gas goes on decreasing. The next question is why chlorine is not often used in swimming pool water directly. Now we know that chlorine is a toxic gas. It is a toxic, poisonous gas. So we cannot use directly it to pool. Instead of that, we use chlorine releasing compounds, which is the chlorine containing compound which gives out chlorine gas on dissolution in water. We use that. Since a toxic poisonous gas, it can cause harmful effects. It can be harmful if you use directly. Hence, we do not use chlorine directly to swimming pool water. Instead of it, we use chlorine compounds of chlorine, and these chlorine compounds are added to swimming pool water so that they release chlorine gas slowly and disinfect. Okay, so that should be the answer for the part D. Now part E says HOCl ionizes to form hypochlorite ion, OCl minus ion. That is, HOCl is dissociating to form OCl and H plus. HOCl is forming OCl minus and H plus. This is the reaction. The graph is between the HOCl concentration and OCl concentration, and then we can see that initially the fraction of HOCl is 100%, and as the pH goes around 5.5, this HOCl dissociates and converts into OCl minus and concentration becomes 0. That is, the dissociation starts around 5.5 and completes at around 10 pH. HOCl completely dissociates from OCl. Similarly, for OCl minus, around this pH of 5.5, this OCl is more in concentration. OCl concentration goes on increasing and become maximum at around pH of 9. Okay. Now what is asking? Deduce the pH range where the water is most effectively sterilized. One more thing is, he's saying HOCl ionized to form OCl minus, which is less effective disinfectant. Which is less effective? OCl minus is less effective disinfectant. Since OCl minus is a less effective disinfectant, the more the OCl, less will be the effectivity towards sterilization. Now we can see the pH range from 0 to around 5.5. 0 to 5.5 we have HOCl in higher concentration, and since HOCl is in higher concentration, it is more effectively sterilized. So deduce the pH range where the water is more effectively sterilized. The answer should be around 0 to 5.5 should be the answer. Why? Because at this concentration HOCl is present in maximum amount and OCl is present in less amount. 0 to around, we can say 5.5 or 6, around 6 we can say. Because around 6 it started increasing and it started decreasing. So 0 to around 5.5 or 6. Okay, next is part 2 says that determine with reference to the graph in P, the pK of HOCl. We have to find out the pK of HOCl. Now we know for a pair of conjugate acid and bases, pH is always equals to pKa plus log salt upon acid. And when the concentration of the salt is OCl minus, which is a conjugate base, and the acid is HOCl, when the concentration of these two are equal, the pH becomes equals to pKa. Okay. Now from the graph I have to find out the point where the concentration of this HOCl is equal to OCl minus, and we know at this point the concentration of HOCl and HCl, they are equal. Concentrations are equal, and the corresponding pH of this line is around 7.5. pH when HOCl is equal to OCl minus is 7.5. Therefore, pKa equals to 7.5. That should be the answer. Now this question F, one part F, says ammonia released from sweat and urine reacts with HOCl to form a range of compounds including chloramines. Chloramines are formed. Deduce an equation for the formation of dichloramine, which is NHCl2, from ammonia and HOCl aqueous. We have to write an equation for this question. The equation will be ammonia NH3. Whenever we are writing equation, we have to write the states. NH3 aqueous reacts with HOCl aqueous to form dichloramine, which is the main product, NHCl2. Along with this, water will also be formed, which will be the byproduct. NHCl2 state is aqueous again, and water will be liquid. And we have to balance this equation also. There are two chlorine on the right hand side. If I put 2 in front of HOCl, chlorine balanced. There are 5 hydrogen and 2 oxygen, so I have to put 2 in front of water. Now this equation is balanced. 1 mole of ammonia reacts with 2 mole of HOCl, gives you 1 mole of dichloramine and 2 moles of water. For this equation, I will get 1 mark. Next part B of this question is the graph shows a molar ratio of dichloramines formed at different pH at 25 degrees Celsius. Trichloramine NCl3 causes pool water to smell bad. So when NCl3 is present, a bad smell comes from the pool water. The molar ratio of chloramines formed at different pH is given to us. First is chloramine, second is dichloramine, and third is trichloramine. 3 are given in the graph. And from the graph, I can say molar ratio and pH. There is a graph between molar ratio, percentage of molar ratio versus pH. Chloramine is basically found under pH of about 8. That is, it starts formation from about pH 3-4 and goes till 8, maximum at 8. Whereas dichloramine is maximum at about pH 4.5 and trichloramine is maximum around pH 2. So this is the first interpretation of the graph which I can see from the graph. Now what the question is asking, state 2 conditions needed to prevent bad smell, and bad smell is because of NCl3. So I have to prevent the formation of NCl3. So by this graph I can see NCl3 is formed at lower pH and the formation of NCl3 starts around pH 5.5. So if I keep the pH of the solution, if we keep the pH of the solution of the reaction above 5.5, then formation of trichloramine will not take place as per this graph. The first, now this question F, one part F, says ammonia released from sweat and urine reacts with HOCl to form a range of compounds including chloramines. Chloramines are formed. Deduce an equation for the formation of dichloramine, which is NHCl2, from ammonia and HOCl aqueous. We have to write an equation for this question. The equation will be ammonia NH3. Whenever we are writing equation, we have to write the states. NH3 aqueous reacts with HOCl aqueous to form dichloramine, which is the main product, NHCl2. Along with this, water will also be formed, which will be the byproduct. NHCl2 state is aqueous again, and water will be liquid. And we have to balance this equation also. There are 2 chlorine on the right hand side. If I put 2 in front of HOCl, chlorine balanced. There are 5 hydrogen and 2 oxygen, so I have to put 2 in front of water. Now this equation is balanced. 1 mole of ammonia reacts with 2 mole of HOCl, gives you 1 mole of dichloramine and 2 moles of water. For this equation, I will get 1 mark. Next part B of this question is the graph shows a molar ratio of dichloramines formed at different pH at 25 degrees Celsius. Trichloramine NCl3 causes pool water to smell bad. So when NCl3 is present, a bad smell comes from the pool water. The molar ratio of chloramines formed at different pH is given to us. First is chloramine, second is dichloramine, and third is trichloramine. 3 are given in the graph. And from the graph, I can say molar ratio and pH. There is a graph between molar ratio, percentage of molar ratio versus pH. Chloramine is basically found under pH of about 8. That is, it starts formation from about pH 3-4 and goes till 8, maximum at 8. Whereas dichloramine is maximum at about pH 4.5 and trichloramine is maximum around pH 2. So this is the first interpretation of the graph which I can see from the graph. Now what the question is asking, state 2 conditions needed to prevent bad smell, and bad smell is because of NCl3. So I have to prevent the formation of NCl3. So by this graph I can see NCl3 is formed at lower pH, and the formation of NCl3 starts around pH 5.5. So if I keep the pH of the solution, if we keep the pH of the solution of the reaction above 5.5, then formation of trichloramine will not take place as per this graph. The first condition needed to prevent bad smell is the pH should be kept greater than around 5.5 or 6. The pH should be greater than 5.5 or 6. Second condition is, as we know, there are 3 moles of chlorine in NCl3, 2 moles in NHCl2 and 1 mole in NH2Cl. So it shows more the Cl2, higher will be the chances of formation of NCl3. So what I can do, I can reduce, what I am saying was, more the NCl3 will be formed when the concentration of Cl2 is higher, because there are more moles of chlorine. When Cl2 is higher, more moles of chlorine will be there, and it is generally formed at lower concentration. What could be the answer? Part 2, the concentration of Cl2 or HOCl, which is also the chlorine compound, chlorine is coming from HOCl, should kept low. And that can prevent formation of NCl3 or bad smell. Suggest 2 reasons why operating a swimming pool. Next question is part G. 2 reasons he's asking. Operating a swimming pool at low temperature is favorable for the environment. Now when I'm operating swimming pool at low temperature, we know that the solubility of chlorine in water was an exothermic process. And when I'm keeping temperature low, it means low temperature will have more solubility, more of chlorine in water. There's less frequent disinfection is required. Less frequent disinfection is required. We have to use less amount of chlorine, or we have to use less frequent disinfection of the swimming pool water, because the solubility is higher, it will remain in water for longer time. Okay. Next is, if I am using swimming pool at low temperature, then at low temperature the evaporation of water also decreases. There's loss of water is prevented. Hence it is also less amount of water is required to less frequently refill the pool. Okay, so these are the 2 answers which can be favorable to environment, because if you use less amount of chlorine, then it will be added less to the environment. And number 2, if I am using low temperature, then water loss will be less, and loss of water will be less through evaporation, hence lower amount or less amount of water is required to refill again and again. Okay, these are the answers for the question number 1. Paper is, a student investigates the effect of exposure to the air on the ascorbic acid, which is vitamin C, concentration in a specific orange juice. Equal volumes of orange juices are sealed into identical flask and placed in a refrigerator for 2 weeks. The same samples in the refrigerator are exposed to the air by removing the stopper for different number of hours each day, as shown in the diagram. Now these 5 flasks shows the first orange juice was exposed to 0 hours and the last one was exposed to 24 hours. 0, 1, 2, 8 and 24 hours. This is the question statement given. The part A of this question says identify 2 variables that are controlled. So we have to identify controlled variables in this experimental procedure. The first controlled variable, as we can see, is the equal volume. All of these containers have same volume. First they are controlling is the volume of the orange juice is constant. The first controlling variable is volume of orange juice. What can be the second variable? The second controlled variable could be specific orange juice. That is, same type of orange juice should be taken. The second controlled variable could be same type of orange juice. What could be other options? He's asking 2, but what could be the other options also? The other option could be they should be refrigerated for same time. Refrigerated for same time. So you have to write any 2. Refrigerated for same time. So this should be the two controlled variables. The part B says concentration of ascorbic acid is determined by titration with standard iodine solution, which is iodometric titration. Few days, 10 centimeter cube of orange, every few days, 10 centimeter cube of orange juice is removed from each sample and diluted to 100. 10 is diluted to 100 and then titrated. Question suggests why the juice diluted before titration. So when we are diluting this orange juice from 10 centimeter to 100 centimeter, we are increasing the volume as well as decreasing the color. So as to decrease, the question says why the juice is diluted before titration. So when we are diluting the 10 centimeter cube to 100 centimeter cube, 10 centimeter cube is diluted to 100 centimeter cube. Question is why we are diluting. Since we know orange juice is a colored solution, and for colored solution, to identify the end point easily, we have to dilute it. Since the end point since it's a colored solution, the end point will also, that is the color of the end point from blue black to colorless, that can hinder. Hence we dilute the solution to maximum dilution possible. Number one thing is to identify the end point clearly. So what I can write, why it is diluted? It is diluted to identify end point easily. So in this type of question, whenever the solution is colored, and this dilution will be used for colored solutions which have their own color, and when you titrate, the end point can intermix with the colors, so as to identify the end point easily or clearly, we can dilute them to decrease their own color intensity. Okay, so the first thing is to identify the end point, or next point, or why we are diluting, we can also say to increase the volume so that more trials can be done. We can increase the volume of solution so that more trials can be done. 10 is converting to 100, 10 times we are increasing so that we can perform more trials. So this could be the two answers of part B. The second part of this question is you have to identify a possible systematic error with this method regarding the sample that is exposed to 0 hours. When we see this question statement, there is a sample which has been kept for 0 hours, and when you withdraw the solution for titration from this, there will be exposure to oxygen or air. Hence the solution or the ascorbic acid present in this container can react with oxygen or get oxidized. So this could be the systematic error. What I will write here is, when the flask was opened for taking out solution, to withdraw solution, there will be exposure to oxygen, to air or oxygen, causing oxidation of the ascorbic acid. This is your systematic error. At 0 hours also there will be oxidation because of the oxygen. When you withdraw, when the flask is open to withdraw solution, there will be exposure to air, or we can also say there can be air within the flask also, that can also cause oxidation. That can be the next point, air within the flask or air enters when you open the flask, both could be the answers. Next, part 3 suggests how an additional flask could be set up to verify whether the systematic error in 2 has occurred or not. So now in this question we have to verify whether the systematic error in 2 has occurred or not by using an additional flask. Now what you do when you are using an additional flask, we have to compare that additional flask by the result of the additional flask with the previous section 2 results. So what you can do, how you compare is, you can eliminate the error by filling the flask with inert gas. Instead of air, you fill the flask with inert gas. Inert gas could be argon, could be nitrogen, argon, Ar, could be N2, which do not react with the solution or which prevents oxidation. So when we are using an inert gas to fill the flask containing solution 1 for 0 hours, we can prevent the systematic error, and then by this we can compare with the error in 2. If there is a difference in reading, that means there is an error. Or what you can also do, you can withdraw the samples or withdraw the sample from the new flask or original flask by using a syringe. This can also prevent the entry of air or oxygen inside this solution. When you use a syringe to compare, or when you use a syringe to withdraw, then there will be less chances of air to enter and cause oxidation. So this can also be done to prevent the systematic error in an additional flask. So these two could be options. Since it is only 1 mark, so you can write anyone to get 1 mark. Okay. Now the next part says the following data are collected during a titration, and he had given us final burette reading, initial burette reading 16.10 plus minus 0.05 centimeter cube uncertainty and 0.05 centimeter cube in the second one. When we have to find out the volume of the solution used, you have to subtract the final minus initial. 16.10 minus 1.10, that comes out to be 15.0. This is the volume, and whenever we are using addition or subtraction of data values, then the uncertainties are always added. Therefore 0.05 and 0.05 comes out to be 0.1 plus minus 0.1, which is the uncertainty. The formula for percentage uncertainty is equals to the uncertainty upon actual value into 100. Actual value into 100, the uncertainty is 0.1 upon actual value is 15 into 100. That comes out to be 0.7%. 0.7%, that is the answer. The following graph shows the student results. The titration which he has carried out and calculated the results that has been plotted on the graph, and the axis is time in days and ascorbic acid concentration in mole per dm cube, 10 to the power minus 3 mole per dm cube. And one more axis is the daily exposure of air 0, 1, 2, 8 and 24 hours. There are 5 graphs representing the 5 variables of days and hours. The first question is calculate the average rate of decrease in ascorbic acid concentration for the 24th hour sample over the period of 14 days including units. Over the period of 14 days, this is completely carried out from 0 to 14. Experimentation is done. So we have to calculate the concentration average rate of decrease in ascorbic acid concentration, which can be calculated by finding out the concentration of ascorbic acid on the day 1 and day 14 for 24 hours. At day 1, the concentration of ascorbic acid is around 2.534, around 3. On the 0 day, the concentration of ascorbic acid is 5.4 or 3. We can take approximately 5.3. 5.3 or 5.4. I think it is 5.3 better. It is 5.3. 5.3 is the concentration of ascorbic acid on the day 0. And as time passes, it goes on decreasing, and on day 14, it comes out to be around 1.1 or 2. Around 1 point, I can take 1. Change in concentration now comes out to be change in concentration equals to 5.3 minus 1.1. 5.3 minus 1.1, and common is 10 to the power minus 3. This is change in concentration. That comes out to be 4.2 into 10 to the power minus 3 mole per dm cube. This is change in concentration. The time is 14 days. Therefore, rate equals to change in concentration upon time, change in concentration upon time taken. So that will be 4.2 into 10 to the power minus 3 upon 14 days. So that is 4. It will be 3 into 10 to the power minus 4 mole dm cube, that is per dm cube to the power minus 3 days to the power minus 1. This is the answer for this. And since the question is saying including units, so we have to write units should be included, and this will give you 1 mark and 1 mark for the final answer. Okay. Next question is question 2 part 2. The student's hypothesis is a lower ascorbic acid concentration will be found in juice exposed to air for longer time due to oxidation of ascorbic acid by oxygen. discuss whether or not the data support the hypothesis. Now, as we see the data, the ascorbic acid concentration goes on decreasing with time, and for 0 hours and for 24 hours, the ascorbic acid concentration is lower. For 0 hours, it is higher, and for 24 hours, it is lower. Ascorbic acid concentrations goes on decreasing as time passes because the exposure to oxygen goes on increasing. Thus, my question is asking whether or not the data support this hypothesis. Yes, the data supports. Data is supporting the hypothesis. Supports the hypothesis. Since concentration of ascorbic acid goes on decreasing. Since we can see concentration of ascorbic acid is decreasing. It is visible, it is decreasing. Okay, and it is maximum for sample at 0 hours and minimum for sample at 24 hours, exposed to 24 hours. This is 0 hours and 24 hours. Okay. Next, we'll get 2 marks for this question. Number 1 mark will be it supports. 1 mark will be that it is supported, the hypothesis supports the results, supports the hypothesis, or the hypothesis supported by the results, and lower concentration for higher time, that is for 24 hours, and maximum concentration for lower time. Okay. Next is state the implications of the results of the experiment for avoiding loss of vitamin C in storage of orange juice. Now, when we are storing orange juices, we have to prevent loss, and by this experiment we found that higher the time for which vitamin C is stored, lower will be the ascorbic acid, or after opening, after exposure to oxygen. If you keep this vitamin C exposed, not exposed to air, in a sealed container, it can be used for a longer time. So you can increase the shelf life by, number 1, using the orange juice within few days of opening the can. Number 1 question answer should be this. Number 2 should be store the container at low temperature and sealed. Store the container at low temperature, or store the orange juice in sealed container. We can also write store the orange juice. Instead of this, I can write orange juice at low temperature in a sealed container. Low temperature in a sealed container. In a sealed container, so that it do not get exposed to oxygen and can be used for a longer time. Suggest an extension to investigation. Now he is asking you extension of the investigation, which is just like your IA, that would generate further recommendation for the storage of orange juice. Then I see this experiment is basically done for days at a constant temperature, and the other variables that can be used here for extension could be storing or finding the effect of temperature on different type of on the storage conditions, or storage conditions on the content of vitamin juice. Number 2, it could be that type of orange juices. Type of orange juices could be fresh orange juice, fresh, canned, etc. These 2 could be the main important extensions which can be added to the given experiment. Okay, so that's all about question number 2 of this. Okay, this question is question number 3 of the paper, of this IB paper, and this question says a student investigates the effect of pressure on the volume of CO2 gas released from a carbonated drink. So what we are taking a carbonated drink in a container and we are collecting CO2 gas in this gas syringe. We are also putting masses. To alter the pressure on the carbonated ring, masses are placed on the top of the piston. If the masses increase, the pressure goes on increasing and on this gas. The data collected for this and the graph is plotted. Graph is plotted between volume of gas and time in seconds. And 3 experiments were conducted. Experiment 1 without any weights. Experiment 2 200 grams of weight. Experiment 3 400 grams of weight. And by the help of this graph, we can see that the volume of the CO2 gas collected goes on decreasing as the weight goes on increasing. This we can interpret from this graph. This is my analysis of the graph. Now, question 1 is determined by annotating on the graph the initial rate of release of CO2 in experiment number 1 in centimeter per second. As we can see in the initial rate of CO2 in experiment number 1, so whenever we have to determine initial rate, the graph should be plotted from 0. Graph will be plotted or tangent will be plotted from 0 point. So we will plot a tangent from 0, that is at time t equals to 0. If you plot a tangent on this graph 1 at time t equals to 0 and find the slope of the tangent, we will get the initial rate. If I draw tangent, since I am doing it on my tab, you have to do it on a physical paper so you can draw it properly, but it should come around this point. This should be my point. And if I draw vertical line, so it should be around this line. This is my vertical line. Therefore, the R, which is my initial rate, R will be change in volume of CO2 upon change in time. Now change in volume is from 0 to 40. This is 0.0. If a tangent is drawn from 0.0, it's from 0 to 40 approximately. It is from 0 to 40 approximately. It is from 0 to 40. Change in volume of CO2 is around 40. 0 to 40 means 40 is the change in volume. Change in volume of CO2 is around 40. Okay. Now change in volume is 40. Therefore, initial rate R equals to 40 upon this change in time is from 0 25 and approximately 35. Change in time is also around 35. If I draw a line, it will come around 35. If a line is plotted here, it will come around 35. Okay. Thus, change in volume is 40 and change in time is 0 to 35. Therefore, initial rate will be 40 upon 35. That comes out to be 1.14 centimeter cube per second. That will be the unit. I hope you understood. We have to plot a tangent at the point 0, and the gradient of this tangent or the slope of the tangent will give you the initial rate. So this is your initial rate. Initial rate, which is R. Okay. Now estimate the time at which the piston would begin to move if 600 gram of mass is used. Instead of 400 gram, if I use 600 gram, then what will happen? Now in this case, if I see when no mass is used, then the volume was about 33. When 10 gram of 200 grams of mass is used, piston will begin to move. The piston will begin to move around time 10 seconds. This is the time. When we increase the mass to about 400, then piston is about to start moving around this point, which is 25. When I'm increasing the mass to 600, I can estimate that the piston will move around. There's a difference of 5, then 10, and then around 15. 1, 2, 3, 15, 25, 30, 35, 40. The piston will move around, start moving around 40. So my answer should be the piston should move around 40 seconds. That should be the answer. Okay. Next, suggest 2 reasons why the volume of CO2 collected in the gas syringe is smaller when more mass are placed on the top of the piston. So what I mean is, question says, if you increase the mass, if you increase more and more mass here, the volume of the gas collected here will be smaller. This will decrease. Why this happens? Because if I increase the mass on the piston will apply more force on the gas. The gas will compressed. At the higher pressure, the volume will decrease. Along with it, when we apply force here, the CO2 gas again goes back and start dissolving in this. So there can be 2 answers for this. Number 1, he's asking 2 also. 2 reason is, number 1 reason, why the mass of the gas or the volume of gas collected is smaller. The volume of CO2 gas collected here is smaller because as mass increases, the pressure on the gas goes on increases. Thus, gas is compressed to lower volume. First reason will be this. Number 2 reason is, as the mass increases, pressure increases. Thus, more of CO2 gas starts dissolving back into the carbonated drink. If you increase pressure, gas starts dissolving. Higher the pressure, more will the dissolution of CO2 gas in the carbonated drink. Hence, lower volume. So these are the 2 reasons why the volume could be lower if you increase the mass. Okay. Now the D part is, calculate the percentage decrease in the final volume of CO2 per 100 gram placed on a piston using result of experiment 1 and experiment 3 at 100 seconds. At 100 seconds for experiment 1, if I talk about experiment 1, at 100 seconds, we can observe that the volume of CO2 gas collected is 31, 32, 33. 33 centimeter cube is the volume of CO2 gas collected when there is no weight for experiment number 1. For experiment number 2, the volume of CO2 gas collected for this is 10 and 11, around 10.5 centimeter cube or 10.4 centimeter cube. Okay. 33 is for when there is no mass, that is experiment 1, and 10.5 is for experiment 3 when the mass is 400 grams. Now the percentage change is asking, percentage decrease will be equal to initial volume minus final volume upon initial into 100. That is, initial volume is how much? 33 minus final volume is how much? Final volume was 10.5. 33 it is 11.5. Volume is 10 and 1, 11.5. This is 10 and this is 11 and then 11.5. Yeah, 11.5 is the final volume. 33 minus 11.5 upon 33 into 100, this is percentage decrease. But he's asking per 100 gram. This is for 400 gram, therefore it is 400 divided by 400. The answer comes out to be 33 minus 11.5 upon 33 into 100. This is the percentage. And per 100 gram will be 100 upon 400 because it is the total change for 400 grams. When I calculate, the answer comes out to be 16.28%, which is approximately equal to 16.3%. So that will be the answer for this 1 mark question, but you have to calculate all this. Next question is sketch a graph. Sketch and give reason for a graph the total mass on the apparatus in the experiment 1 against time. Total mass versus time, we have to construct a graph for experiment number 1. Total mass of the apparatus versus time. If I see this experiment, the gas is released from this container and it's going into the gas syringe. That is, although a gas is released in this experiment, but this gas is going and get collecting in this gas syringe. And syringe is also closed, there is no leakage, we consider there is no leakage. Hence, when I calculate the total mass of this complete apparatus, the mass should remain constant with respect to time because there is no loss in mass. No loss in mass as the gas syringe is closed. Gas syringe is closed. So we are considering it as a closed system without any leakage. Closed system without any leakage, and the total mass will remain constant with respect to time. Therefore, you can draw any horizontal line on this graph. Any horizontal line on this graph will give you the mass versus time. Any horizontal line on this graph, if you take a scale and draw it properly, any line on this graph, anywhere you want, you can draw. No problem at all. Yeah, this is like this. A straight line should be there. Use a proper scale to draw it. If I'm doing it on a hard copy paper, and I would have done it by the help of a scale, a straight line graph. Okay, so this is the answer for this question. Why a straight line? Because there is no loss in mass and it's a closed system. So this completes your paper. So whenever you are doing this paper, what we have observed while doing all these 3 questions, that is more or less the paper is based on your chemistry knowledge, and the applied part of chemistry, which is your course, has to be applied in experimental procedure. Experimental data is collected and your chemistry knowledge is applied there. Whether it is a knowledge of redox reactions, acid bases, solubilities, or pH curves, whatever it is, you should know the complete course along with what is operating, what is happening in this particular experiment, and what is the chemistry involved in that experiment. That experimental knowledge you should have so that you can get a better score in this paper. Although there is a very broad course, we cannot compile it in few questions, but whatever question comes, you have to apply your knowledge in terms of chemistry. Then only we are able to score a good mark in this paper. Read the question carefully. First think what is asking and then start doing, because even if we do it, we have to read it about 2 or 3 times and then we can find out the exact answer which should match with the answer key. If your answer will not match with the answer key, it is difficult to score marks. Okay, thank you for this paper. Bye bye.